Section 10.2, solving quadratic equations with the quadratic formula. So the quadratic formula is something that you do need to know. Since this is an online class, I guess maybe you don't have to have it memorized, since you can use a note card on your final and everything else is done with your notes at home. But if you happen to have it memorized, that would probably make life a little bit easier. So the quadratic formula is an equation that can be used to solve any quadratic function. And it's just by substituting the values for A, B, and C in place in the correct location in the formula. And so if we're going to solve with the quadratic formula on part A, the A is 2, the B is 11, and the C is 15. And so I'm just going to substitute. So I have the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. A couple of notational things just to be careful that I've seen happen many, many times. One is to make sure your fraction is underneath the entire expression, not just the last part of it. Also make sure your square root goes all the way over to the end of the C value. So then we solve it using order of operations. Underneath the square root of 121, 4 times 2 times 15 is 120. And so underneath the square root is 1. And the square root of 1 is 1. And then I can split this up into 2 problems, and I only split it up and actually solve it all the way when I don't have a square root anymore, which is the case here. So I have negative 11 plus 1 over 4 and negative 11 minus 1 over 4. And simplify the fraction. So my solution set is negative 3 and negative 5 halves. So that one worked out nicely. The square root was able to be solved. And what that really means is that this could have actually been solved by factoring, but the directions said to use the quadratic formula. On part B, before I use the quadratic formula, it's important to make sure that it's equal to 0. So I need to go ahead and move that 4y . And then when I use my quadratic formula, the A is 1, the B is 4, and the C is negative 2. So x equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So we get 16, and then multiplying these together, we get plus 8. 16 plus 8 is 24. And then I'm going to simplify the 24. 24 is 4 and 6. So it's going to be 2 square root of 6. And then I also broke up, instead of one big fraction, I did 2 smaller fractions, much like we did with the imaginary numbers. I do this because it's easier to simplify. So then I simplify and I get negative 2 plus or minus the square root of 6. For my labs, you probably have to list those separately. Just make sure you follow the instructions on my labs for how to enter your answer. Part C. So our setup of our initial equation is kind of strange. I have this k in the denominator. If I want to get this k out of the denominator, I'm going to multiply everything by k. So if I multiply by k, I get 16k squared plus 9 equals negative 24k. And then like on letter B, I have to make it equal to 0. So I'm going to add the 24k over to the left-hand side. And now I have it set up to solve with the quadratic formula. We have A is 16, B is 24, and C is 9. So we get negative 24 plus or minus 24 squared minus 4 times 16 times 9, all over 2 times 16. (24 squared is 576. 4 times 16 times 9 is also 576. We end up with the square root of 0, which is just 0. And then 24 over 32, that simplifies by 8, and we get negative 3/4. So we just have that one answer this time. So keep that in the back of your mind. We'll come up to this again in just a moment. When you have a 0 under your square root, how you're just going to have one number for your answer. One more problem to do. So our A is 1, our B is 1, our C is 2. Substitute it into the quadratic formula and then do your work. We end up with a negative number underneath the radical. So using our imaginary unit that we talked about in the last chapter, we have negative 1 and 7. And also splitting up the fraction, I have negative 1/2 plus or minus I square root of 7 over 2, or written as two separate answers. And that's how we use the quadratic formula to solve a problem. Something that goes along with the quadratic formula is called the discriminant. The discriminant is the expression that's under the radical in the quadratic formula, the b squared minus 4ac part. And how it's important is it tells us how many and what type of solutions there are without actually solving the problem. So I have this organized in a table. If the value of the discriminant is positive and a perfect square, like we saw in example 1, part A, because we had a positive 1, then we get two solutions that are rational, meaning they are integers or fractions. If you have positive but not a perfect square, you still get two solutions, but they're irrational, meaning you're going to have a radical answer. And we saw that in part B. In part C, we saw the 0, and then we had one answer. It's called a repeated root, and it is rational, meaning a fraction or an integer. And then if you got a negative, you have two answers, but they're complex or imaginary, meaning there is the I in the answer. So actually solving these problems, we're going to do that in the next video, just to break things up a little bit. So come on back for the next video.